Program studi memiliki akreditasi A, Badan Akreditasi Nasional Perguruan Tinggi (BANPT), dan akan menuju ke akreditasi unggul serta bersiap untuk bergerak menyiapkan akreditasi internasional. Teknik Industri UIN Sunan Kalijaga, mahasiswa siap berkembang menjadi industrial engineer yang unggul dan berwawasan keislaman. Assalamualaikum warahmatullahi wabarakatuh.
Salah satu program studi di Fakultas Sains dan Teknologi UIN Sunan Kalijaga, Yogyakarta. Program studi Teknik Industri memperoleh SK Pendilian pada tahun 2005 dan mulai beroperasi pada bulan Agustus pada tahun yang sama. Program studi Teknik Industri di UIN Sunan Kalijaga merupakan sebuah berkah atas adanya transformasi tahun 2004 dari IAIN atau Institut Agama Islam Negeri. Dalam proses perjalanannya meraih akreditasi yang dimulai pada tahun 2008 mendapatkan akreditasi C, kemudian mengajukan reakreditasi di tahun 2013 mendapatkan akreditasi B, dan selangkah demi langkah namun pasti pada tahun 2018 mengajukan reakreditasi kembali hingga mendapatkan akreditasi A. Sebagai bagian dari Fakultas Sains dan Teknologi UIN Sunan Kalijaga, program studi Teknik Industri memiliki visi menjadi penyelenggara pendidikan tinggi teknik industri yang unggul dan terkemuka serta berwawasan nilai keislaman. Dalam upaya mencapai tujuannya, program studi Teknik Industri menetapkan misi, di antaranya mengembangkan pendidikan dan pengajaran yang berwawasan keislaman dalam bidang teknik industri, melaksanakan penelitian dan menghasilkan publikasi dalam bidang teknik industri yang
Okay, before agenda is started, please enter your name based on format name _ affiliation. We would like to invite all participants of the webinar, The Advanced Manufacturing, to enter the Zoom meeting and please open your camera. Okay, all participants, please open your camera. Agenda is started. Okay, Assalamualaikum warahmatullahi wabarakatuh. Respectable the Dean of Faculty Science and Technology State University Sunan Kalijaga Yogyakarta, Dr. Hajah Hurul Wardati, respectable the Coordinator of the International Webinar Touring Faculty Teknologi Kejuruan Mekanikal dan Pembuatan UTIM, Profesor Joseph Sahaya Anantangaraj, Honorable the Head of Industrial Engineering Faculty of Science and Technology State University Sunan Kalijaga Yogyakarta, Dr. Cahyono Sigit Pramudyo STMT. Honorable all participants, student from UIN, student from UTIM, and of course, all invited guests. Good morning, ladies and gentlemen. My name is Rara. It's a precious chance for me to be your Master of Ceremony on this very special occasion, the webinar Advanced Manufacturing. First of all, let's say thanks to Allah Subhanahu wa Ta'ala who have give us guidance, happiness, healthy, and mercy. So we can attend and participate in this special event without any obstacles. Praise and salutation upon our Nabi Muhammad who has brought us to the path of the light from the darkness in this life. I would like to welcome Dr. Fariza Abwahab, Senior Lecturer, Faculty of Mechanical and Manufacturing Engineering Technology, University Technical Malaysia Malacca, and Dr. Rusna Dwijayanti, ST, Master Engineering PhD, Lecturer, Industrial Engineering, Faculty Science and Technology, State University Sunan Kalijaga, Yogyakarta, as our speaker today, and all of the audience. On this special morning, we have several agenda as follows. Number 1 is opening. Number 2 is Tilawatul Quran. Number 3 is singing national anthem from Indonesia, Indonesia Raya and Negaraku. Number 4 is speech from Dr. Cahyono Sigit Pramudia as the head of Industrial Engineering Faculty of Science and Technology, State University Sunan Kalijaga, Yogyakarta. The next is speech from the coordinator of the webinar Touring Faculty UTIM, Professor Joseph Sahaya Anand Tangaraj. And then presentation and discussion section from our speaker, Dr. Nur Fariza and Dr. Husna, and the last is closing. Ladies and gentlemen, to begin the opening ceremony is Tilawatil Quran, who will be recited by Dikri Ahmad Firdaus. So, Mr. Dikri, time is yours.
Jangan Gorit. Oh, mana mau kayaknya.
Sorry for the trouble of the techniques. We can next the agenda is singing national anthem from Indonesia and Malaysia.
Banyak.
Okay, move on to the next agenda is Tilawatil Quran. Tilawatil Quran will be recited by Mr. Dikri Ahmad Firdaus. So Mr. Dikri, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim.
Itu naskah apa kalau ada dibaca ditanya?
Bismillahirrahmanirrahim. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Wa fakihatin katsirah la maqtu'atin wa la mamnu'ah wa furushin marfu'ah inna ansha'nahunna insha'a فجعلناهن أبكارا عربا أترابا لأصحاب اليمين ثلة من الأولين وثلة من الآخرين وأصحاب الشمال ما أصحاب الشمال في سموم وحميم وذل من يحموم لا بارد ولا كريم إنهم كانوا قبل ذلك مترفين وكانوا يصرون على الحنث العظيم وكانوا يقولون إذا متنا وكنا ترابا وعظاما أئنا لمبعوثون على سرر موضونة متكئين عليها متقابلين Sadaqallahul azim. Assalamualaikum warahmatullahi wabarakatuh.
Bukan.
Thank you, Mr. Dikri Ahmad Firdaus. May Allah bless us. Amin. Well, ladies and gentlemen, let's begin this event by reciting Basmalah. Bismillahirrahmanirrahim. And the next agenda is speech. The speech will be delivered by Dr. Cahyono Sigit Pramudio, STMT, as a head of industrial engineering. For Mr. Cahyono Sigit Pramudio, time is yours.
Okay, thank you, Ms. Rara, for this opportunity. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Honorable Dean, Faculty of Mechanical and Manufacturing Engineering, Professor Joseph Sahaya from University Technical Malaysia, Malacca. Our Dean apologizes for not being able to attend this event because Dr. Khurul, our Dean, she has another agenda. On this occasion, I would like to express our gratitude to Dr. Nur Fariza from University Technical Malaysia, Malacca, and also Dr. Husna for being able to be the speakers for our webinar today. And also thank you for all audience who joined this webinar. I hope this event may initiate more collaboration between our university, especially from Department of Industrial Engineering and Faculty of Mechanical and Manufacturing Engineering, University Technical Malaysia, Malacca. And also I thank to Dr. Ikhwan Ghazali for bridging our collaboration. Hope we can continue our collaboration, more collaboration, and other colleagues that joined this event. Just now, Dr. Ririn from Atmajaya University, Yogyakarta also joined this event. Thank you for joining us, and some of our colleagues also joined this webinar. Finally, I hope this webinar will benefit to all participants. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, the next agenda is speech. The speech will be delivered by Professor Dr. Joseph Sahaya Anan Tangaraj as a coordinator of the International Webinar Touring Fakulti Teknologi Kejuruteraan, Mekanikal dan Pembuatan UTIM. To Professor Joseph, time is yours.
Thank you very much, MC, for giving me this opportunity. A very warm good morning and welcome to this webinar, Advanced Manufacturing. This is such a first event, a collaborative event, especially for our Faculty of Technology, Engineering in Mechanical and Manufacturing, University Technical Malaysia, Malacca. On behalf of UTEM, as well as the State Islamic University, Sunangan Kalinja, Indonesia, we welcome all the participants for this webinar. We really hope that this seminar will be beneficial for all the participants because we have good speakers, and though they are going to deliver us in their respective field, but though it is their specialization, we hope it also benefit us, especially technologist Dr. Nur Fariza Abdul Wahab, who is also my personal friend. Also thanks to Dr. Husna from the State Islamic University, and we are very eager to be with the session. And this is also an event that we bridging together with these universities. And I hope this will be a platform for all of us, not just attend only today. It will continue forever in terms of any academic collaboration, also the research one. And not forget to thanks at this occasion, Dr. Ikhwan Ghazali, for introducing us to this particular event. Thank you very much. And as in UTEM, currently we are ongoing with the 16th convocation from yesterday until Sunday. So on behalf of our Dean, Associate Professor Dr. Omar, he apologized for not able to join because due to the convocation event, and wish him all the
Rara, you can continue.
Thank you, Mr. Joseph, for your speech. Move on to the next agenda is our main agenda, presentation and discussion section from our speaker, Dr. Nurfariza and Dr. Husna. In this agenda will be led by our moderator, Mr. Hamdan. But before starting the presentation, please open your camera to take a photo or a screenshot. Thank you.
Okay, there is a 5-layer 5 screen in this meeting. Right now, I will take one by one. Okay, the first screen, 1, 2, 3. Okay, the second screen, 1, 2, 3. The third screen, 1, 2, 3. The fourth screen, 1, 2, 3. And the last screen, 1, 2, 3. Okay, thank you for your opening camera. Next for Nahaba.
Okay, thank you. Okay, in this agenda will be led by our moderator, Mr. Hamdan. To Mr. Hamdan, time is yours.
Check, am I audible?
Okay, clear.
Okay, thanks. Okay, thanks for Ms. Nahaba for the time. Let me introduce my name. My name is Hamzah Hamdani. I am a student in Industrial Engineering Department, Islamic State University, Sunan Kalijaga. And here I will be the moderator for this seminar. I will lead our main agenda, which is presentation and discussion about advanced manufacturing. In this main agenda, we have two amazing speakers, ladies and gentlemen. They are Dr. Nurfariza from UTEM and also Dr. Husna Dwijayanti from Islamic State University, Sunan Kalijaga. Before we start our agenda, let me introduce our best speaker today by read the curriculum vitae. First speaker is Dr. Nurfariza. Okay, Dr. Nurfariza is the senior lecturer, Faculty of Mechanical and Manufacturing Engineering Technology, University Technical Malaysia Malacca, and also they have the professional summary in also as the coordinator of innovation and intellectual property, UTEM Commercialization Center or UCC, Office of Deputy Vice Chancellor Research and Innovation, and other professional summary. And also on her qualification, in the last qualification as she got as PhD 2012 until 2015 in Tokyo University of Agriculture and Technology, Tokyo, Japan, and other qualification. And also she has experience as senior lecturer right now in University Nelika, Malaysia. And also in the research grant, the last research grant in 2020 until 2021 in ASEAN and SAP Collaborative Holistic Research with the title, The Impact of the Glare Effect During Daylight Towards the Driving Performance of ASEAN Users, and other research grants, ladies and gentlemen. And also in the publications, she also has a lot of the publication in the last 5 years, and also in academic award. She also got in innovation. She got a gold medal in MTE 2020 and other academic awards. And also that is the profile of our first speaker in our seminar today. And also in our second speaker is Dr. Husna, ladies and gentlemen. Dr. Husna is the lecturer in Islamic State University, and also in their last academic qualification, She are graduate from Integrated Design Engineering, Keio University, Japan, and also she has experience in job in PT Komipo Pembangkit Jawa Bali, PT KPJB Coal Fire Power Plant, PLTU Tanjung Jati in Jepara West in Java. Okay, and also in the public international in publication international. She also has some journals already published in international. For example, in International Journal Paper 2015, SCOPUS in Index, and also another publication that she already released. Okay, maybe there is the profile from our best speaker today, ladies and gentlemen. Now we will start the presentation sections. And without further ado, I call our first speaker to deliver her speech. For Dr. Nur Fariza, time is yours.
Okay, thank you. Thank you very much.
Okay.
Okay, Bismillahirrahmanirrahim. Thank you very much for the invitation. Thank you to our MC, Ms. Rara, and also our moderator, Mr. Hamzah, also the Dean of the Faculty from UIN and Dr. Husna, and also to my coordinator, Prof. Joseph and Dr. Ikhwan for inviting me to sharing just actually a short experience about my field in advanced manufacturing. So my name is Nur Fariza. I'm from University Technical Malaysia Melaka under the Faculty of Mechanical and Manufacturing Engineering Technology. I'm very nervous right now. I do hope that the audience can share some feedback if I quite fast in speaking or sharing with you guys. Okay, thank you. So today's agenda is actually one about me, a little about me, and then introduction to the University Technical Malaysia Melaka, UTM. Also introduction about our faculty and what is manufacturing process actually, and why do we need advanced manufacturing process, which is AMP. Some sharing on current research and development on AMP, and also some what should we call hands-on prototyping through universities to frontliners. So I will skip this one. I start my education from diploma until PhD actually in Japan for about 12 years. I did my diploma from Oshima Maritime National College, which is in Yamaguchi. I took electronic mechanical actually at that time. So from bachelor, masters and PhDs, I did my degree in mechanical engineering. I've been exposed to advanced manufacturing was during my PhD, which I did my thesis on modeling of cutting process and flow stress under high strain rate. So from 2015, I've been a senior lecturer at these universities, and currently also the coordinator on innovation and intellectual property of Commercialization Center UTM under the Office of Deputy Vice Chancellor Research and Innovation. So some introduction about our university. We are situated at the UNESCO Heritage Site of the historical city of Melaka, which is quite near to Indonesia, Yogyakarta. So we basically come up from Malaysian Technical University Network, which we have 4 technical universities under this network. We have UTHM, ours, UNIMEP, and also UMP. If you can see the map here, our main campus is actually just 130 kilometers far from Kuala Lumpur, which is our main city. So we are proud as a pioneer on practice and application-oriented teaching and learning methodology for higher technical education in Malaysia since 2000. For your information, we have 2 campuses actually. This one is our main campus, and we are here at the technology campus, which also we call as the industrial campus. So just briefly about Tunai concept, which our lead vice chancellor concept actually. We have like academic for 8 faculties. We also have like exercise program, which included PhDs, master's, bachelor, and also diploma. Currently, we have like 10,000 almost student enrolled, and among them, we have like 700 come from international student. Our research need area is advanced manufacturing and also computing technology. So what is a Tunai concept actually? It's about technology at universities advancing industry. So in terms of student development, we are proud to say that we have like 86% graduate probability on 2018, and also we have about 26,000 alumni since 2005. So I'll skip this one also. So I would like to play some videos from our corporate. I'm so sorry that I cannot upload it to my PowerPoint. Can you see my screen? Can
Yes,
you
ma'am.
also hear the voice?
Yes,
The
better.
sound? No. So I'll play again. How about this time?
Maybe because before you share screen the video, you can checklist on the bottom left, the share sound.
Share
share
sounds,
sound.
right?
Yeah.
Can you hear now?
Oh, okay. That is
Okay.
good.
Is it in a full screen or just half of the screen?
Half of something.
So basically, we start as a technical university in Malaysia. Since 2008. is actually about our universities. I also will play a video about our faculty. What we have in house types of machine. So this is our faculty. As I said, it's very good at international or what is it, process. We have a key program, which is manufacturing
Sorry, doctor, your voice is mute, still mute.
Okay, sorry. The video just now is actually what we do have in our faculty, all the high-tech and advanced machine in-house. So to continue from that, I will just go directly to why do we need advanced manufacturing process actually. Okay, why do we need advanced manufacturing process? Advanced manufacturing process is the use of innovative technology to improve product and processes, with the relevant technology being described as advanced, innovative, and also cutting edge. Advanced manufacturing industries increasing integrated new innovative technologies in both product and also processes. So this is the example of the major drive of advanced manufacturing process, which is through material, process, and also operational. The aim of advanced manufacturing process is to actually enhance the output, which is increase the added value, quality, and also responsive to market and flexibility. In the other hand, it's also to reduce time to market, upgrade the unit quantities, reduce the material content, and also to reduce material inventory. So what do we have actually types of advanced manufacturing process currently? We do have additive manufacturing, which is the most popular right now is 3D printer. Okay, we also have an advanced composite materials. We play around with nature and also fiber composite. We also have types of advanced manufacturing in robotic and software automation, laser machining welding, nanotechnology, and also network IT integration. So I will share some what I did, what I am doing right now, especially in my research, current research, and also development of on AMP. This paper is actually published this year. We studied about spindle speed effect on CFRP, which is stand for carbon fiber reinforced polymer material. Currently, I'm also playing around with nature composite, which we study the effect of process using laser cut and CNC router on plywood sandwich laminate. So this is our laser cut that we can operate at a bigger size. This is our CNC router in our lab. So we compare the effect of the advanced manufacturing process in the same material and then study the output. Next one is about the effect of process using laser cut and also CNC router, but this time we use jute laminate composite. Same again, I compare the effect of process of advanced manufacturing process to this composite. So what I'm so eager to share actually on this webinar is about how we actually apply advanced manufacturing process from universities to our frontliner. We did this project from last year until now. So University to Frontliner is actually an experience of FTK-MP at UTM in producing face shield using advanced manufacturing process for mass production. So this one is actually begin since our first MCO, 18 March last year. We team up as a laser team. At that time, Malaysia need to lock out for, I think, almost 5 to 6 months. So at that time, what we did was that we built up a team to use a laser to produce face shield. So this is actually our premier design by using 3D printer that being shared through 3D community at Malaysia. But we decided to use the same design by using laser cutting. So this is the machine and how we set up in our lab on the material. So we have the big size of material, which is acrylic, and then we test the parameter to set up. This one is on the process of design optimization. We have version 1 here, version 2, and also version 3. The difference is actually at this neck round over here, where we do get some feedback that it's quite easy to break. So we improve and then we decide to use the final design, which is V3. So how we did the process of design optimization is actually we run through analysis using SolidWorks, and then we managed to come out and choose the best parameter at this area. So this is the output by one layered size of acrylic. We managed to produce at least 20 to 30 pieces per unit. However, through this process of advanced manufacturing process, we do have another second process which we need to take out the stickers on the acrylic. So it's quite time consuming. Another thing that we did during this time was that we used the same design but using selective laser sintering, which is additive manufacturing processes, one of the popular one also, which we have in-house. So by using this machine, actually one time we can produce maximum 100 to 150 units per day. So this is the output. The left side is the output from SLS 3D printing, and at the right side is the output of the face shield by using laser cutting. As I said before, so this is the thing that we need to manage afterward. We have a lot of waste, so we need to improve on this one. Thus, by using acrylic, actually it's quite brittle, so we do have some feedback that we need to modify what types of material that you want to use to produce a face shield. So end up, we managed to produce about 2,500 complete units by using both methods. However, we do still want to improve the process. So we start again, starting from April 7, to do a real mass production in UTM. This is the team, included with 17 academic from our faculty. We revise again the design because this time around we want to use injection molding machine, which is the base material is from plastic. So this is the machine that we have in our lab, injection molding machine. We installed the new mold, which is sponsored by FETA Autopart Industrial Sdn Bhd, which is situated in Malacca. It's a local company. They sponsored the mold for our injection molding. So this is how we install the new mold. If you can see at the right side, this is the mold design that we use to produce the face shield. This is how we try and setting all the parameter, and this is the right side is actually the first output from the machine. If you can see, it's still not completed at this side. So this is final output from injection machine molding process. As you can see, we have another second or third process which you need to take out this neck, and we also need to trimming to make the face shield mask more user friendly. So we also have some sponsors, another again from Petronas Chemical Group Berhad, which they sponsor almost 100 tons of material. And then this is me doing the trimming process of face shield frame, and then also need to do hands-on on PVC film just to make a hole so that we can assemble it to our frame. This one also sponsored by STM Microelectronics Sdn Bhd. So we go on with the mass production, packaging. Output from using the advanced manufacturing process, actually per day, by using this machine, we managed to produce almost 1,000 units of face shield per day. So this is the outcome. At the last side, we're packing the face shield 100 pieces per box, and this one 300 pieces per box. So what we did was that we do distribute the face shield to all the frontliners. We also distribute to school to also firefighters and police. This is some of the feedback and impact of using advanced manufacturing process in-house. This also, I think that's all that I can share about what we did by using advanced manufacturing process in-house at our faculty.
Hamdan?
Okay, or can I open to any questions while waiting for our moderator?
Sure, Doctor. You can
Yep.
open a quick discussion.
Okay. I would like to hear any feedback or questions from our audience, if there is any.
Hamdan, please read the question from the chat room.
Okay, Haris, since you raised your hand, do you have any question or any feedback for it?
Hamdan has problem with the mix. Sorry. Okay, let
It's
me
okay.
replace Hamdan for a while. Okay, I think there is one person who raised hand, Haris. Would you like to deliver your question directly to Dr. Nur Fariza?
Hello, Dr. Fariza. Assalamualaikum.
Waalaikumsalam. Okay.
I just want to know what was the biggest challenge that you faced when you do this project, since we had MCO at that time. Could you tell us what was the biggest challenge?
Oh, the biggest challenge will be that if we still remember, we do have some restriction on which industry can be open or which sector that can be open. At that time, if I'm not mistaken, it's just some sectors of universities and also industry. So that's why even when we got some sponsors from the industry, we just can have it in a partial time by time. It's not like everything in one time because of the MCO. And then because of the MCO, almost all the raw material from KL, we cannot get it till here. So that's why we survive with the industry around UTM and Melaka. Thank you, Charis.
Okay, I think I read from the chat room, so we can the same question. I think the same question from Mr. Muhammad Zulfian Abdul Razak.
Yeah.
Okay. Okay.
I think, Dean, we have a question about nanotechnology here. This one is from
Yes. Bintang.
Bintang, yeah, from Surabaya, Indonesia. I would say that I cannot give a good feedback about this because nanotechnology is not my field, but we do have expertise in Faculty of Manufacturing and also our faculty. Maybe after this we can discuss later more the details about the contact person or anything about it.
Okay. Mr. Bintang, you can go detail next. This is from Mr. Haris. I think he's still asking about the how
He's
to
just my
secure the
friend.
sponsor. Oh, Okay.
Thank you so much for coming though. Okay, I will answer his question. Okay, sustain on the sponsorship is actually we do have, if I can share my slide here. Currently, actually, where should I share? Can you guys see my screen right now? Okay. So this is actually still in our website of our universities where we do have a tabung bencana UTM. So from this tabung, we will ask time by time. Depends on the demand of user. So actually this tabung is still active, and for those who want to give some money and donate some money, they still can give it here. And then we, as the manager of that project, we just ask from the tabung for us to use the money to buy all the materials and essential parts of the project. I hope that answers Mr. Haris' question.
Hamza, you can continue to be a moderator this webinar.
Okay, sir, because there is some trouble. Okay, I can. Okay, maybe for the next question. Okay, if there is no any question, maybe we could continue to our next.
I think
speaker.
Hamza, sorry, we do have like one last from Sasi. I'm not sure.
Okay.
Or she.
Yes.
May I know the cost of the project? Okay. If you want to calculate the project of face shield by pieces, at that time it will cost around RM2. I'm not sure in rupiah how many, but RM2 is how much? Hamza, in rupiah?
Maybe
7,000. Okay, thank you.
Yeah.
I think it's about 7,000 rupiah. So, but we are quite sure at this time we can still minimize the cost because we do have a lot of material around comparing during the first MCO in Malaysia. Okay, how about the quality standard use, sampling or checking every product? Okay, that one I will honestly say, current time being, even until now, we just naked eyes. We don't have any specific like industry to control every product at the quality QC, quality control department. So it's really by a naked eyes.
Okay, thank you for the question.
Thank you.
Maybe we could continue to the next question in after Dr. Husna already delivered her speech, right? Okay, let's continue to our next speaker is Dr. Husna. For Dr. Husna, time is yours.
Thank you very much, Hamza Hamdani. Dr. Nur Fariza, Hamza Hamdani is my student, and all of the committee for this webinar, all of them are students. And I would like to thank to Dr. Nur Fariza and then Dr. Iwan Ghazali. Now I will share the screen. Is my screen appear? Hello, is my screen appear?
Yes, yes, clear.
Yeah. Today I would like to talk about computer integrated manufacturing in the CAD/CAM area, focusing on the computer aided process planning or CAPP. This is a part of my research in Japan. Now I will okay. Hey everyone, my name is Kusna Dwi Jayanti. I finished my bachelor degree in the industrial engineering, Gajah Mada University, Indonesia in 2007. And then I continue the S2, which in Indonesia we call S2, Master Engineering in the Engineering Design and Manufacturing, University Malaya, Malaysia in 2010. So saya bolehlah cakap Melayu sikit-sikit, Dr. Nur Fariza. And then I continue the doctoral degree in the Integrated Design Engineering in Keio University, Japan in 2015. And Dr. Nur Fariza is from agriculture technology.
Yeah, Tokyo University.
Tokyo.
Yeah. Boleh bahasa Jepun juga?
Agriculture. Boleh sikit.
Okay.
I'm from Keio. I graduated from Keio University, Japan, and Keio University is in Yokohama. And then the outline for my presentation today will be introduction about CAPP, and then the CAPP on the multitasking machining, and the overview about smart manufacturing.
Sorry, Dr. Husna.
Yes.
Maybe your slide doesn't move.
Really?
Yes.
The outline?
It's still in the first slide.
Oh, really? It's now okay? Outline?
No, it's still in the first slide.
Okay, I will repeat the screen sharing.
Yes, it's clear.
How about now? It's clear? Okay,
Clear.
Now outline is clear. Outline.
Second slide.
Second slide is okay.
You may view the PowerPoint, the presentation file.
Yes. Is it okay now?
Have you made it as a slideshow?
Yes. I need to
No, we cannot see it.
Oh. How about like this?
Yes, we can see that.
So why I cannot make slideshow? Oh.
Maybe you need to open in the slideshow mode first and share screen and choose the slideshow mode.
Okay.
For the
Okay,
share screen.
I will try. I'm sorry for this trouble. I think like this is okay. Sorry for this inconvenience. For the outline for this presentation, today's presentation, I would like to explain about introduction of CAPP, and then the CAPP on multitasking machining, and then about overview of the smart manufacturing. And my doctoral degree research in Keio, Japan is development of automatic process planning system for turning milling center based on machining feature recognition. So this time, I would like to explain to the student about how to make a simple automatic process planning with the SolidWorks API. Next, for students, I want to ask you, do you know about multitasking machining? Hamza, do you know multitasking machining?
Yes, Miss. Yes, Doctor.
What is that?
As long as I know, is multitasking is combined in some process that include in one machine. So in the some process, maybe this
yes, correct. Yes, correct. Multitasking machining is machine that combine multiple process to reduce number of operation. And multitasking machine have both turning and milling function. And the parts are produced using multiple setup in one machine. And this time I will explain about the process planning in the multitasking machining for complex parts. Computer-aided process planning is a bridge between design and manufacturing. So we can say that process planning is from CAD to CAM. Here is the design process, and then we do the process planning, and then we can do the manufacturing. So we can CAPP is the bridge between CAD and CAM. For the definition, process planning can be defined as an act of preparing processing documentation for the manufacturing. And the basic process in the developing process plan, the first is analysis of part requirements, and then selection of the workpiece, and determining the manufacturing operations and sequence, selection of machine tools, and selection of tools, and the last is determining the machining condition. And now we move to the case study. For example, if we want to make a target shape like this, so what is the process? What is the sequence? Which one is the first? In the process planning, the machining features, identify the process, identify the sequence, cutting tool, tool path, and processing time. And this process needs machining feature recognition. Usually in the manufacturing, the process plan and sequence is determined by humans. Humans do the process planning. For example, the senior worker or the expert worker, by their experience, they determine the sequence. By making a system, process planning system, the system will give suggestion to the user or to the worker about the many alternative candidates of machining plan and simulate them and give them suggestion. For example, about which machining plan will provide the best results. Here is the method, recognition method. First is combine target shape, and the second is disassembly. Then identify the surface, recognize features, generate the sequence, identify the process, and evaluate and select the process plan. And all of these steps designed by using SolidWorks API with the Visual Basic Application Language. So if the student learn the API, you can make any automatic system with your own by study about API. And here is we move the case study. For example, if we want to make a product like this, how to make the process planning for this product? In the upper side, there are many features, and in the front side also have features. For the right, they also have many features in the bottom, at the back side, and also in the left side. So what is the sequence? Which side will be machined first? Upper side or right side or front side, like this. So that's why we need a process planning system to, there are many alternatives to machine this product. So that's why we need to build a process planning system. And the first way to make the process planning is to get the delta volume. This is very simple. First, you have the target shape from the CAD, and then you have the workpiece or blank shape, then combine target shape and the blank shape, then you will have the delta volume or material to be removed. Material to be removed on the machine. So this is the new idea, is working, making a process planning based on the delta volume. There are many ways to create process planning. Some of researchers use from making process planning for the target shape, and some of research, the new idea is making process planning from delta volume or material to be removed, because the material to be removed contain many information about the machining process. That is the idea. And then after obtain a delta volume, the next step is cut the delta volume or disassembly the delta volume into small piece, small machining features like this. For example, if this part cut to be this one, so cutting the delta volume here like this. Different way to cut the delta volume create different machining features. For example, here the machining plan, alternative plan number 1 have 16 machining features, and the machining plan number 4 have 19 machining features. So different way to cut the delta volume, make the different process plan and also different sequence. The next, after obtain the delta volume disassembly, we start doing the machining feature recognition by identify the surface. By identify the small surface of this, we can know about the body dimensions, surface number, type of surface, and then we got the type of machining features. After obtaining the machining feature type, the next is tool selection. After we have the machining features, we can determine the tool type and the tool diameter. And the next is the toolpath length calculation. Select the toolpath type, and then the output is the type and length. The next is time calculation. We know machining feature, we know the tool, we know the toolpath. Then the next is calculation the cutting time, and then calculating the air cut time, and we can obtain the processing time for each simple machining features. Then we can obtain the total time, or the total processing time for a particular process planning candidate. Here is the picture of the many alternatives of process planning and sequence by cutting the delta volume in different way. And then the process planning system will analyze which process planning or which machining plan candidate have the best result. For example, have the shortest processing plan. And then here is the result, the example of the machining plan number 1. Here, number 1. The machining plan number 1 has 14 removal shapes, and then the number of surfaces like this, and then the machining features we can determine from the number of surfaces. This by the simple logic. And the operation type is determined automatically from the machining features. And the machining features is determined automatically by the number of open and closed surface. And the machining plan candidate number 1 is different with machining plan number 4. In the number 4, it has 19 machining features here, and they have also different sequence and different operation of machining features. So here is the example of there are different machining plan, and the system will calculate and also simulate the process planning and evaluate the best candidates. Here is the time evaluation for each candidate. For example, here there are 16 machining plan candidates, and here is the total time. From this table, we can see that the machining plan candidate number 1 has shortest machining plan. So if the evaluation criteria is total time, we can see that the best candidate is the candidate machining plan number 1. It has machining features, 14 machining features, and the processing time 7.5 minutes. And the machining plan number 4 here, they have 19 machining features and the total time 7.8 minutes. So here you can see the comparison of different process plan, and the system will select total time. And the system will give suggestion to the user about the best process planning candidate in terms of total time. So this is the just a simple explanations about my research in Japan. And now I will move to the next agenda, the next outline about the overview of smart manufacturing. Or in the smart factory, I want to ask students how to control many machines in the same time. Do you know how it works? If you have many machines, and then how to control many machines in the same time and in the real time? Do you know let's see the video. This video is about the smart factory of Nakamura Tome in Japan. Mr. Host, please share the video of the smart factory. Just to give the students overview about the smart factory.
Hey guys, this is the Nakamura Tome channel from Japan. Today's theme is the smart factory. I will tell you some tips to keep your machine running all the time. How about your factory? For example, this machine has stopped. If you use anti-smart sign, an email will be sent to your smartphone once the machine stops in alarm status. Besides, you can leave alarm is occurred. You can immediately contact the operator to restore the machine. The more machine you have, the harder it is to manage. From this screen, you can check the stop time, setup time, alarm occurrence time, and operation history of each machine. From this information, you can improve the efficiency of each machine. It is also important to manage the programs. By using the input and output function of anti-smart sign, the program can be managed from the office remotely in a batch. It prevents from making a selection mistake. If you access the anti-smart sign from the PC in the measurement room, you can directly input the offset correction value to the machine after measuring the part remotely. Of course, it is necessary for managers and operators to communicate well. You can use the chat functions to communicate with field operators without leaving the office. That's all for today. Thank you for watching. If you like it or if you think it was helpful or for any other reason, please subscribe. Our next video will introduce the compact loader and part catcher. Please don't miss it. Sayonara!
Okay, that's all for my presentation. I hope the students understand about how the process planning system for complex parts are obtained in the automatic process planning system. Thank you very much. And now is the discussion session. If you have questions, please ask directly or write in the chat room. Thank you very much.
Okay, Dr. Husna, thanks for the presentations. To all the participants, if you have any question, you can unmute yourself and ask question, or you can put your question in the chat box. Or maybe we have a first question, or maybe if you have a question for Dr. Nur Fariza, it's also allowed if you have question for the previous presentation. First, from Aisha, maybe you could more make clear about your question. As Aisha, you can unmute yourself if you have question. Okay. From Aisha with a question, with an integrated system, is it like system application and product in data processing, SAP? The question for Dr. Husna.
Aisha is Miss Aisha is from Malaysia or Indonesia with an integrated system. Oh, okay. My system my CAPP system is created by me, not with the application like CAP. I create the process planning system with the SolidWorks API. So by a SolidWorks API, inside the SolidWorks, there are SolidWorks API and it's open access. So you can go there and then access the API and then make your own code and then make your own system inside the SolidWorks API. In my case, I am making the CAPP system. The input is the CAD software, is the CAD design and also the CAD design of the workpiece. And then I obtain the delta volume data. And then by SolidWorks, the system automatically disassembly the delta volume into small machining features and then generate many process plan candidates and then evaluate the best processing plan. I hope Miss Aisha, I hope it's clear. Oh, thank you. Thank you very much.
Okay, thank you for the question, Miss Aisha. Maybe we have the next question, Dr. Rusna. Is the machine can recognize the complex features such as curvy surface and etc.?
Thank you, Mr. Muhammad Sultan. This is not machine. Is the machine can recognize the system? Is the system can recognize the complex features such as curvy surface? Yes, curvy. You means spherical, cylindrical. It can be recognized, but my system cannot recognize the, the free form. How to say, the free form features. How to say, my system can recognize the planar and then cylindrical and then spherical, but cannot recognize the free form surface because it's difficult to determine the parameter for the free form surface. And one more question from Mr. Zulkarnain. Dr. Husna, how you ensure that your process planning is reliable and can be used at machine? This process planning system is a basic, idea, basic, how to say, basic study. It is a basic study, and the output is only suggestion for user. So in this stage, I still not insert the output to the machine, directly to the machine. Just give a suggestion in the computer to the engineer or to the worker in the machine. So it's
Maybe that is the answer from Dr. Husna. For Mr. Zulkarnain, maybe is there next question or that is enough?
The system such as fan blade. For the blade, for Mr. Muhammad Sufyan, fan blade is a complicated shape. So the system can make the delta volume or the removal material and split the delta volume. But if the curvy is too complex, my system still cannot recognize that. But if the surface is like sphere, round, something like that, the system can recognize the surface.
Okay, how is there any question? Or maybe for the student, if you have difficulty to ask the question in English, you can
Thank
use
you,
Indonesia
Mr.
or
Muhammad Sufyan.
okay.
Yes, for student UIN, please you can ask in Indonesia or in Melayu or in English.
Okay, we have one raised hand from Mr. Sigit. Maybe you can answer.
Okay, thank you, Hamza. I have two questions. The first for Dr. Nurfariza. You mentioned that the cost of the product is ringgit. I still for make sure that you consider the cost for the machining or the cost like depreciation cost. Did you include that cost as as how you count to ringgit for each item of the face sales. This is the first question, and then the second question is for Dr. Husna. Do you have any idea to continue your research in our laboratory facility maybe in a small scale, for maybe because we still don't have the master program, so can the undergraduate program continue, although it's very small very small scale? I think that's all my two questions. Thank you.
Okay, this.
Okay, thank you, doctor, for your question. I will try to answer that one, though I don't have the proper calculation actually, how we came up by that RM2. If we are familiar with the mole machine process, actually the raw material will come in a one package. I should share. So how we calculate it is by actually through the one bag of raw material. And then we assume that, if I can share my screen. So, okay, so this is the bag that packaging that we get from as a metal PPE, which stands for poly something, but I'm sure it's a plastic. So how we calculate, actually by one packet of raw material can produce almost maximum 1,000 pieces of face shield per day. So by let's say this one is like 110 ringgit, and then divided by 1,000 pieces per day. That's how we come up with 1 ringgit per unit. But it doesn't include the raw material for the shield of our face. So the frame itself will be around 1 ringgit to 150, and then included with the PVC film, which is 5 cents. So that's how we calculate it to become 2 ringgit. It's just a simple calculation. As I mentioned, that one is if we target per day to produce 1,000 pieces unit per day. But let's say we reduce the numbers, so the cost will increase. Thank you.
Okay, thank you, Dr. Nurfariza, for the explanation.
Maybe the next question for Dr. Husna, you can answer.
Thank you. Thank you, Dr. Cahyono Sigit, for the question. Is it possible to continue my research in our laboratory? Yes, it's possible. because to make process planning system, we just need first we just need computer, and then SolidWorks, and then we access the SolidWorks API. But before that, the student must learn the language, programming language. In the SolidWorks API, it can be accessed by C++ and also VBA, Visual Basic Application. So I think the student must learn the Visual Basic Application first, and then they can start to learn the SolidWorks API. And learning, my professor in Japan said that learning API is very difficult in the beginning, but after you learn, you can make any system, any automatic system based on the CAD design. So it's very powerful tools to make an automatic system. And I think for the undergrad student, we can make a simple process planning system for simple product.
Okay. I add some comment. Thank you, Dr. Krishna, for the explanation. I just want to inform also, give information to Dr. Nurfariza and also Dr. Ivan Ghazali. This year or last year, we start the collaboration with University Teknologi Malaysia with Professor Nurdin Muhammad Yusuf, because our faculty, one of our faculty, Dr. Dwi, is graduate her master from UTM Malaysia. So we conduct the collaboration research by joint supervision for undergraduate student. So I think this is an interesting opportunity to start the process, because we start with the advanced manufacturing. So I just trigger the idea from the Dr. Husna Dr. Husna research. So maybe Dr. Ivan or Dr. Nurfariza can make joint research with Dr. Husna related to the advanced manufacturing process. But unfortunately, we still don't have the master program, so the level will be on the graduate program. It's very simple, I think, like Dr. Husna mentioned before. So I think it's very interesting. And one of the research is published for the international conference. So it is very interesting because Dr. Nurfariza and Dr. Ivan is from the manufacturing research stream. I think it's very interesting to have joint collaboration in this research area. Thank you. It just informed Dr. Nurfariza and Dr. Ivan. And also for my students, Dr. Husna is open for continuing his dissertation, his research. Just you need more effort to learn for API, for SolidWorks, and also for application for Visual Basic Application. I think that's very interesting if you can continue the research, although the level will be very low because it's in undergraduate program. Thank you. Just a little comment for the research opportunity. Thank you.
Thank you. May I respond?
Okay.
Yes, please.
Thank you, Mr. Sigit. Actually, I'm Indonesian, from Indonesia, and also study in Jakarta long time ago in Ahmad Dahlan and Gajah Mada, and I met Dr. Husna when I did my PhD in Keio University. And that's why when I hear CAPP, it seems like I open my memory again when she present with Prof. Oyama long time ago. So I know what she did. I know. Okay, to respond the opportunity. Okay, I'm the one of the coordinator for international relationship in our faculty. So it is very possible to do joint collaboration and etc. Yeah? And also, if possible, we can also try to do a meeting with our team for the first beginning meeting, yeah, to know what is the desire between between faculty. And also, we actually try to make what is that now collaboration with Uprim also to as an approach for international collaboration. And for WIN, this is also possible because I already informed to the dean about the rank and also about the profile of WIN Kalijaga, yeah, because I know much about WIN and I know the location and everything. I also know about WIN, yeah. So it's possible. Maybe later we can contact with Mr. Husna, Ms. Husna, Dr. Husna and Dr. Nur Fariza, and also we can do the collaboration with other topic, not only for manufacturing process. If your lecturer have interest and also your student have interest, we can do collaboration in another topic also. I will try to find the suitable researcher in our faculty. Thank you, Dr. Sigit.
Thank you, Dr. Irfan.
Okay, Dr. Maybe if you have a question, Dr. Iwan Ghazali.
I think no question. I just want to inform him like Mr. Sigit. This
Okay.
is about the collaboration opportunity. Yeah.
Okay, thank
And
you.
also with maybe if the student from WIN want to continue master or PhD in UTEP, okay, you can contact me. I can help you to arrange everything.
Okay, thank you. That's nice offer, Dr. Irfan. Thank you.
Okay, for the next discussion, maybe Dr. Husna, we have a question from Muhammad Suhaizan. Dr. Husna, from the Japan Video Smart Factory, it seems that the machine have a monitoring or control system via PC or mobile. The question is, the system already being installed in the machine or the machine can open for integration of such as monitoring or controlling system.
Thank you very much for the question. In the video of the smart manufacturing, it's the machine controlled by, sorry, I cannot see the chat. Please repeat the question.
Okay, I already sent the question.
It seems that the machine have a monitoring or controlling system via PC mobile. The question is the system already being installed in the machine or the machine can open for integration of such monitoring controlling system? Yes, the system is already installed in the machine, and so the managers and also the worker, the technician, can directly get a notification about the machine condition, and also they can communicate through the computer, central control computer. And also it's embedded related with the smartphone or mobile device. And it can be accessed from the area and the factory area, and also can be accessed from outside using the internet.
Okay, that is enough, right, for Muhammad Okay, we have the next question for Dr. Nur Fariza from the facial project under predictive performance. May we know what is the percentage failure rate of the product? Is there any sensitive issue on the machine that cause the failure?
Okay, I don't have the exact numbers of the percentage failure, but what I can share is for the first setup, at least almost 100 pieces of face shield is not perfect. So you just need to increase and optimize the parameter. And after that, it should be okay for just one set of setup on the machine. The machine cost the failure, okay, that one will be totally depends on the parameter of the machine and also the types of material that you use. So currently, since we just have one types of material and from the same industry, so we know already which and how to set the parameter on the injection molding machine.
Okay, may I continue the question, Dr. Nur Fariza? How you manage the parameter itself? How you know that your parameter is the best parameter for the molding machine?
Okay, if I can share again my slide. Can you guys see my slide now? So
Yes.
this is the final output by our machine. So this is where we try to play around with the parameter, especially for injection molding. The critical parameters is on the temperature of that machine and also the material. So this is the example. Actually, the material is stuck inside the mold itself. And this is also the example how actually the material doesn't fit every angle of the design. If you can see, because the final output should be like this. So how we try is actually just play around with the temperatures and then times of injection. I think that will be the most critical two parameters for injection molding. I hope that answer your question.
Okay. Thank you.
Have you ever seen any injection molding machine?
Yes, I have. I have.
How big is it?
Actually, not in my university, but when I internship in my factory had a problem in injections. We try to find the best parameter by have some like trial and error. Maybe in every step we try to manage. Maybe try 100, and we get the like probability, the best probability, so on and yeah.
Okay, as we know, the best thing about plastic injection molding machine is that even the product is not perfect, we still can recycle the product, right? So
Yes,
that is
but
the advantage of advanced manufacturing process. Actually, we
yes,
can still
but
recycle the product.
yes, but that is still was the time, and we lost the profitability, right? Maybe if there is any question, you not should use English. You can use Indonesia or Malay language. It's okay.
I have question, Dr. Nur Fariza. Is there any product line that manufacture in your faculty?
Oh, we have a lot actually, but I don't have the data, especially on merchandise. I don't have, but what I can, no, I don't have that data now. For example, we do have, we do fabricate some merchandise as a souvenirs for our corporate office to be given to our VIP. We also do some CSR to produce a name card or name tag for our students. That will be some of the project.
We also have next question for Dr. Fariza. For the recycled material was how many percentage of recycled material mixed to the virgin raw material?
It's also my colleague actually. Okay, I don't have the exact numbers, but the recycled material being input to the virgin material is like more or less than 10% from the origin. So it's like less than 10% from the recycled material.
Okay. Whether the waste material is in fact for the result of the output or not actually, if we mix to the virgin material.
No, we didn't do any test on it. We just make sure it can be used, and then that's it. Will be our final quality control check.
Okay.
I have one more question, Dr. Nurfariza. What kind of machine? What kind of machine in your laboratory, in your faculty? Do you have like electric beam machining or water jet machining or what is the laser beam machining, and then ADM, electric discharge machining? Is all of the machine available in your faculty?
Actually, I can't remember well, because at least we have the types of laser. We do have the types of water machine in our faculty. But what I can suggest is actually, or the audience can go to our website. I will share again. So this is our faculty website, and then you can go to the research. No, can go. Okay, you can go to the facilities and click it here, and then you can see what do we have in manufacturing lab. So this is numbers of lab that we have. So how you want to know what types of machine that we have? Let's say abrasive water jet laboratory. Just click it here, and this is the machine that we have. Okay, that's why I say I can't remember, and I also don't know how many that we have. And the things that I also want to promote is about our CNC lab machine. That one will be in here. Sorry. Advanced. So we do have a machine from 3, 5, and the maximum is 11 exists. Sorry, I cannot find it.
Is all of this machine used by the bachelor degree students or master degree?
Starting from degree until PhD, and even industry, they will come to us since they know that we have the capability to produce and use the machine. They will come to us. I think that's the thing that I can share now.
Okay, we have the next question. From the team that have been from to meet the threshold, what criteria that Dr. Fariza used to select all the staff that have been involved doing the threshold project?
Actually, we didn't select because of the MCO. Some of us was quite afraid at that time to come out from their home. So we just run out any volunteers who want to come during working hours, 8 to 5, and also some expert from the mall design, injection molding itself, and admin stuff. So basically, there is no criteria, just for those who want to volunteer to produce the face shield at that time.
Okay, maybe that could answer the question from Mr. Farm Fitri. Maybe is there any question from the audience?
Can I ask a question? Under your faculty, how many programs that you have currently, and how much is the numbers of your students?
Okay, we have around 200 till 250 students for undergraduate student. Now, this intake we have intake on September 2021. We have around 80 students per batch. So nowadays, the number of the student will increase next year. So we have around 250 students.
Okay. Okay, I think that's all from me too.
Okay, maybe if there is no any questions, maybe we could close our presentation and discussion section in this seminar. Thank you for Dr. Husna and Dr. Nurfariza for the speech, and I hope we could take the benefits and the knowledge and the experience from their presentations. Thank you so much. Already want to share with us with your knowledge and your experience. And also thanks for coming for all the participants. Okay, maybe me as a moderator, I will give my time to a Master of Ceremony, Miss Rara. Time is yours.
Thank you, Mr. Hamdan, and thank you for Dr. Nurfariza and Dr. Hurna for your presentation. And please give a round of applause our speaker today. Okay, finally, we come to the end of this event. To close this event, let's recite Alhamdulillah. Bismillahirrahmanirrahim. Okay, well, ladies and gentlemen, thank you very much for your coming and your nice attention. See you.
See you. Thanks.
Thank you, Dr. Nurfariza.
Dr. Thank you so much. Thank you.
I'm sorry for my signal.
It's okay. Inshallah, we'll meet again in near future to discuss about our future collaboration, inshallah. Thank you so much. Thank you so much.
Thank you so much. Thank you so much. Thank you for student UTEM and also staff. Thank you for joining this webinar. And thank you for the student from UIN Sunan Kalijaga.
Okay, thank you for the participant. Don't forget to to fulfill the absence. Right.
Thank you so much. Adik-adik mahasiswa tetap semangat ya.